Good morning and thank you for joining us today for our webinar for February 2019. And we're looking today at energy retrofits in housing. My name's Katie. I look after the IT and digital side of things here at CABE, and I'll be acting as your moderator for this morning's session. For those of you who've joined us before, you may know the procedure, but we do like to keep these webinars nice and interactive. And if you want to get in touch with us, you can send any questions through either over on the right-hand side of your screen. There's a question panel that you can type your questions into us. Or if you are watching on our YouTube channel, you're still more than welcome to send through any questions. Just email those over to info@cbuilde.com. And today, if you're on Twitter, you can use the hashtag CABECPD. So your presenter, we're welcoming back Professor Phil Jones today. Now, he was with us in October for the Low Carbon Homes webinar. So Phil will be talking us through this morning's session. He's Chair of Architectural Science at the Welsh School of Architecture, and he currently co-directs the Energy Systems University Research Institute. And his research area is in low energy, low carbon and sustainable design in the built environment. So what I'm going to do, I'm going to hand over to Phil. So if you give us a couple of seconds just while we quickly switch this over, and then he will talk you through this morning's session.
Okay. Is that okay, Katie?
That's absolutely fine. All yours.
Okay. So let me start. Good morning, everybody. Welcome to this webinar. I'm going to be talking about retrofit for housing. And my talk will be based on research and some project work that we've been doing in this area for probably nearly 20 years now. So I'd like to acknowledge at the start the ERDF, the European funding that we've had for some of the work that I'll be presenting. I'd like to acknowledge colleagues at Cardiff University who've worked with me in this area. And also Warm Wales is a company in Wales which has carried out large-scale retrofit projects. And I chair the board of directors of Warm Wales, and we've been around now about 15 years in this area. So what I'm going to talk about, I'm just going to make some introduction about why retrofit is important. I'm going to focus on elemental versus whole house retrofits. Elemental being large-scale programs of 1 or 2 or maybe 3 measures, really aimed at scaling up. But whole house is more involved with a package of measures, multiple measures, appropriate to the house type, so very much designed around each house. And at the end, I'll talk about the multiple benefits of retrofit. So let's start with why it's important. We have energy and CO2 targets that we're committed to meet. The targets for CO2 reductions are increasing something like 20% per decade. At the moment, up to now, they've been reasonably easy to meet, but it's going to get much more difficult in future. Domestic energy is around about 28% of the UK's energy demand, and although it's coming down a bit, it's still quite significant. And much of that is for space and water heating. So even though our new houses are efficient in providing space heating, the average stock is still quite inefficient. And although appliances are relatively low, some things are increasing, in particular television energy, since the smart TVs have become popular. So this is, we really have to start to consider retrofitting our housing stock. 80% of the homes that will exist in 2050 have already been constructed, so we're told. New build is less than 0.5% per year, demolition around about 1% a year. So we have an age in housing stock in the UK, with something like 75% older than 1976. And I mention that because it's when building regs really started to look at energy. So we have quite an old housing stock. Many of our houses are still pre-1918. And if we look at the building regulation development since 1965, when energy first started to be introduced, we can see 1976 onwards, there's been significant changes in building regs. And if we compare this with the previous graph, that the majority of our houses are pre-1976, then that illustrates the need to retrofit a lot of our buildings. They would have been designed without much consideration of energy efficiency. Now, 50% of the buildings in the UK, it's been estimated, have had some form of energy efficiency measure installed. And without that, without these improvements since the 1970s, energy consumption in our housing would be something like twice the current level. So a lot has been done, but it tends to have been very piecemeal, and it's addressed really the low-hanging fruit, the easy things to do, the loft insulation, the cavity fill, and usually one or two measures, so very elemental in its approach. So we have a lot of houses with some energy efficiency measures, but they're not enough. Why do we need to retrofit then? In addition to meeting our energy and CO2 targets as a nation, up to 25% of UK households live in fuel poverty. In Wales, it's approaching 40%. And that means people can't afford to pay for their energy. Fuel poverty is when you pay 10% of your income on energy. So what people do is they don't enjoy a warm home. So one of the important needs for retrofit is to create affordable warmth. If we improve comfort, we probably cut out some of the energy savings, because if people can afford to heat their houses, they may spend the money on being warm rather than save the money. So a lot of energy efficient energy saving measures may result in the take back of affordable warmth. Substandard housing in the UK is estimated to cost the health service around £2.5 billion a year, and much of that is due to poor cold conditions. And when we look at the housing stock, the majority of the housing stock, especially pre-1919 dwellings, are privately owned or rented. So the RSLs, the housing associations, are carrying out energy saving measures in social housing, but many of our private houses or private rented houses are not adopting energy saving measures. So there's a lot to do. So what are the measures that we look at? Well, wall insulation, EWI, external wall insulation, internal wall insulation when external wall insulation isn't appropriate. We want to reduce air leakage. If we can reduce air leakage, mechanical ventilation, heat recovery becomes an option, not only for saving energy, but providing good ventilation in the home. Low energy lighting is quite common now. Solar PV, either integrated into the roof. So if the house needs a new roof, we can replace the roof with a solar panel, or it could be bolt on onto an existing roof. And sometimes now accompanying solar PV would be battery storage. So it enables us to store the energy that we generate on the roof and use it later in the day. Other technologies, solar air collectors, the transpired solar collector is a device. It's a metal cladding with holes that draws air in. It's a south-facing panel, and that can provide some preheating of the ventilation. So there are some other perhaps lesser known technologies that we might be interested in. So let's have a look at elemental versus whole house retrofit. What we mean by elemental, I guess, is 1, 2, maybe 3 measures. And elemental retrofit programs are now often large scale. So there may be initiatives by the government. We've had in the past the energy efficiency commitment, now down to the energy company obligation, where energy supply companies are obligated to put money back into energy saving measures. And the recent energy company obligation, Eco 3 now, is specifically targeted at vulnerable households, the fuel poor and other people who have problems in achieving comfort. So the main aim of these elemental large-scale programs has been to cover as many houses as possible. So they tend to put very similar measures in large numbers of houses, and they don't really, or often they don't assess the particular needs of individual houses. So a whole house retrofit service would look at a package of measures appropriate to the house type. So it may look at 3, 4, 5 measures. What is appropriate for that type of house? So it's more tailor-made for the house. So I'll talk about both elemental and whole house retrofit programs. I guess the initiatives that we've had from government that I just mentioned have targeted the large-scale elemental programs. And of course, the Green Deal really never got off the ground. So that probably was looking more at whole house, but it didn't appear to be workable. So let's look at some examples. This is a project that we were involved with in 2004 to 2007, and it was a large-scale program. For nearly 50,000 houses were assessed in Neath, Talbot County Borough Council, of which nearly 29,000 energy efficiency measures were carried out to nearly 19,000 properties. So as you see, there's 1 or 2 measures, maybe 3 per property. Some 10.3 million was invested, and the work included cavity wall insulation, loft insulation, and loft top-up, where the current insulation would be topped up, hot water cylinder insulation, and sometimes boiler or central heating installed where there was a need. As a result of this program, some 10% of CO2 reductions were achieved, even though the measures were relatively small in terms of the cost. Still around just over 2,000 houses were removed from fuel poverty. And these programs also give us an opportunity to do other things. So whilst going around surveying the houses, benefit advice was given to the occupants, and that brought another 2.1 million a year into the local authority in increased benefits. People who weren't claiming the benefit they were entitled to. And that of course, is year on. The project created 54 new jobs and 127 people received training. So we start to appreciate the multiple benefits of these types of programs. And then also there were reported benefits of improved comfort. And we can see from a survey carried out at the end of the program, people felt their house was warmer, it was drier, it was more comfortable, etc. So there were a lot of other improvements that were achieved. Also, there were some housing conditions that were reported to have been improved. Heating was better, condensation risk was reduced, drafts were reduced, mold was reduced, etc. So there are, again, added benefits of these programs. Another scheme which followed on from that in around about 2011 was the first RBED scheme in Wales. And RBED is funded by the government. It's a government-funded scheme to retrofit existing housing. And this scheme was about 7.5 million. Measures were similar, wall insulation, EWI in particular, external wall insulation. These measures also included PV panels and also some fuel switching. And a total of just over 900 properties received one measure. Then a number of properties received two measures, and then only a few received more than two. And the average cost of the measures was around about £7,500, and the overall CO2 saving was nearly 25%. So that's considerably more than the previous project, which was around about 10%. And what we can see in the graph is that the more that was spent on the retrofit, the more CO2 emission reductions achieved. And in particular, pre-1919 houses, the older houses, received perhaps the more expensive measures. They were open to things like EWI insulation, but also the housing stock that we can achieve the most saving. So the older houses, which the poorer performance, get the biggest benefits. And if we compare the measures, the main measures of this survey, fuel switching was obviously the most cost-effective to do. So the savings there compared to the cost per measure, the CO2 savings of nearly 60%, and the cost per measure quite low, averaging about 3,000. EWI is a higher cost and a lower saving, and the PV high cost, lower saving, and there were some solar thermal projects as well. So we can see the relative savings per cost of measure. And I should say perhaps that fuel switching was mainly from oil to gas or electric to gas. So those are some examples of some large-scale surveys. So what I wanted to look at now was start to look at whole house retrofits. And this was a project that we carried out at the university on a small house nearby. And it was part of the UK Retrofit housing programme. And this was a programme to really test what could be applied to our existing houses. This was a small end of terrace two-bed house, and it really had everything done to it. So dry lining insulation, it wasn't, external wall insulation wasn't appropriate. It had roof insulation, added triple glazing. The air tightness is improved. It had a ground source heat pump. It had solar thermal. It had solar PV. It had a mechanical ventilation heat recovery system installed, and their controls were improved. So a lot of measures. And we achieved 80% CO2 reductions, but the cost of this was really high. It was around about £70,000, and it was part of a number of case studies that were carried out at the time, and they've been reported in the book on the top right hand screen, and they were all around about this price, if not more. So really too expensive to consider scaling up. So if we look at where we were after that whole house retrofit, and we compare across the large scale elemental ones, we can get this sort of relationship. As the cost of the retrofit goes up, the CO2 reductions go up. So we've got a group of elemental shallow ones down below £10,000, achieving maybe up to 25% savings. We've got the multiple measures, in particular in older properties, that cost a bit more, and the savings are around about 40%. And then we've got some whole house ones, the one I've included at the top right there, and a couple more that we were involved in. And they take the CO2 reductions up quite a bit, but the cost goes up a lot as well. So what we have is this sort of relationship of the shallow elemental retrofits costing up to £10,000, say, getting about 30% savings. The deep whole house retrofits getting 80% savings, but really too expensive. So our aim was to try and reduce the cost of these deep whole house retrofits and still get that sort of level of savings that we really need to achieve our CO2 targets. So the first major project then we did on whole house retrofits were 5 houses. They were all located in South Wales, a range of age groups, and we looked at whole house, and you can see the top there is the original house, the bottom is the retrofit house. So they all have PV roofs attached. The existing roof was usually in a bad shape, so it was taken off and replaced by this integrated PV system. And there are a mix of, as you can see, a mix of ages and construction types. And the package of measures included reducing demand with insulation, in particular EWI on solid wall. We used internal insulation on where solid wall wasn't appropriate. But some of the houses already had cavity fill insulation, so they weren't improved. And then PV and battery storage, sometimes with mechanical ventilation heat recovery, when it was possible to do without too much disruption to the occupants. So those are the packages. I won't go through them in detail, but if you look at the bottom there, we can see that the costs have come down considerably from the 70,000 that was on the previous case. So they range from about from nearly 24,000 up to just over 30,000. And so the average is around about £25,000. And as you can see, each of them include a package of measures, sometimes replacing the gas boiler when it's inefficient, and that tends to increase then the price of the package. But the measures were selected appropriate to the house type. And when we look at the potential improvements, these were simulated simulations of the energy performance. We're getting CO2 reductions up to 75%, so in the order of where we were before. The more modern houses perhaps are more difficult because they already have cavity fill and there's not so much you can do. And the cost savings up to about in the 80%, the predicted cost savings. So that's very significant. So savings of average savings of about £450 a year on an energy bill of £1,000, and the cost of the whole house retrofit around about £25. So as I said, significant improvements on the 70,000. It might be worthwhile just to look at one or two of these projects in more detail. This was the first retrofit we did of this program. It was a pre-1900s solid wall construction house. It had single glazing, it had an inefficient gas boiler, there was no insulation on the annex flat roof, no fabric insulation at all. It was located in quite an exposed area in South Wales at the end of a terrace. And in fact, this house was unoccupied at this time. It was owned by a housing association, and they couldn't find a tenant for it because of the condition it was in. So this was the improvement. You can see quite an improvement in the external appearance with the external wall insulation applied, the PV roof there, the thermography survey there showing the darker colours on the end of terrace, showing the reduced heat loss. So quite an improvement in appearance and in energy performance. The PV roof was integrated. We used battery storage. Initially, we tried lead acid batteries, but they were not very appropriate, and that was later changed to lithium ion. Low energy lights installed. The external wall insulation was applied, and interestingly, we were able to use aerogel at the window reveals. You can see there, that's narrow strips of aerogel, which is highly insulated and appropriate for window reveals where depth is a problem. And these were available as offcuts at the time, so not that expensive. So, and this tends to be something that we use on all our external wall insulation now. Gutter is a problem. We were looking at ways in which we could detail the external wall insulation around the eaves and the gable end to ensure that there was no ingress of water, and also to ensure continuity of the thermal insulation around that detail. Because the house was unoccupied, it was possible to install mechanical ventilation heat recovery. This can be a problem if the house is occupied because there can be some disruption. But in this house, it was installed, but it has to be in combination with improved, reduced air leakage, because if the building is still leaky, then the mechanical ventilation heat recovery system doesn't really save energy. Although it is quite useful in ensuring good air quality and reducing condensation risk. So this is the house at the end. So before we retrofitted the house, they couldn't rent it. They were looking for around about £400 a month rent. After the retrofit, it was a tenant was found immediately, and it was let at a premium rent. So considerable energy savings, but also making the house give a return on the rental. So again, more than energy benefits. This is another example that I've shown. It's a nice story, really. It's a solid wall construction, again in the Welsh valleys. It's got the PV roof. In this case, we weren't able to apply external wall insulation. It had to have internal insulation on the front elevation because of the stonework. Although there's not much external wall there anyway, it still gives the internal temperature of the wall a lift, so we can avoid condensation as well. The back of the building has external wall insulation. So this saved energy, and the tenant was a single parent mother at the time, and she had a teenage daughter. She reported that before the retrofit, she couldn't get the house warm. She was paying something like £60 a month for gas, and they sat in blankets in the night. The daughter had asthma, was in the doctors every week. After the retrofits, the energy bills were reduced to about, the heating bill down to around about £30 a month, so she reported. They were now warm. They had affordable warmth. And in particular, the daughter's asthma had gone completely. She hadn't been to the doctors once. So again, additional savings other than energy, additional benefits in terms of health and comfort, as well as the energy savings. And the PV roof was performing well. She reported that in the summer months, she was paying around about £5 a month for electricity. And this was featured on an ITV, a local TV program. And she was interviewed, and she was really pleased with the results. So a lot of benefits of retrofitting. So I wanted now to go through a few more examples that we're currently involved in, just to give an idea of what works and perhaps what doesn't work so well. This is again a stone wall end of terrace house. It's in the Welsh valleys, and the aim really of a whole house retrofit is to first do a good survey of the house. Secondly, we want to look at a systems approach to retrofitting, so reducing demand, insulation, reduce leakage, etc. And then look at renewable energy supply, and then look at energy storage. And the third thing then is to simulate a package of measures and make the final selection about what is most appropriate for these house types. So we use computer models to help us predict what the potential from solar PV is. We then look at a package of measures, and here we can see it's a stone wall construction. The internal walls on the front have internal insulation, and the external and gable end have external insulation. It's got a PV roof. In this case, it's east-west facing, so the PV points both ways. And that actually gives us more PV return than just a south-facing roof. And you can see the top of the gable end there. We've got a transpired solar air collector. Now, this is relatively expensive, but we wanted to try this out on this property. And it has battery storage. It has a Tesla battery. And so we analyzed the data in terms of, we can see on the graph there the heating reduction when we introduce the different measures. We can look at the cost of the measures. We can look at the CO2 reductions, and we can look at the electricity reductions. So electricity, heat reductions, CO2 emission reductions, costs of the measures. And we can analyze that and then make a decision about what to do. In this case, we can, probably the most important things are the reduction in energy costs from around about 900 a year to just under 400. The package of measures going really quite high on this one, up to about 48,000, because largely the transpired solar collector, which is expensive at the moment, was an extra cost of about £10,000. So that was perhaps unnecessary on this house. And looking at the payback, we can see around about 73 years, which is quite high. So let's look at a couple of other examples quickly, just to get a comparison. This is a house that we are currently about to retrofit. We've done the survey of the existing conditions, so we look at what's the house is constructed of and what the services are, etc. Then we do this again analysis, and in this case we get operating costs coming down from 1,300 odd to around about just under 300, and the package of measures is around about 46,000. Still quite high, because in this particular house it was oil heated, and we're going to a hybrid oil heat pump system just to try that out, and that's a particularly expensive part of the package. So payback time around about just over 40 years. So again, quite high. Then we've got 3 houses on the same site. Just quickly, again, reductions in cost, this time about just over £500. The package of measures, depending on whether we use a battery storage, or in this case, we will look at maybe putting the excess solar radiation into hot water through an immersion. It's much cheaper. It doesn't give us so much benefit, but the payback is reduced significantly. So we shouldn't go into these projects thinking the same package for each house type. And again, on the same site, about £800 reduction, 33,000 package cost, and retrofit, the payback time around about 40 years. So this is, I don't want to dwell too much on these. This is another project, a bungalow with external wall insulation, and there's insulation over this part of the panel-based construction. In this case, we're looking at a ground source heat pump. And again, the costs. Quite large reductions in costs, about £900 a year. The package costs approaching 50,000, largely because of the ground source heat pump. But there we get renewable heat incentive, which brings the cost down a little bit over time, and the payback around about 40 years. So what I wanted to just the point I'm trying to get over, I guess, is that we really need to think about individual houses and the most appropriate package of measures. So for the first 5 houses we looked at, we were getting something like a 50% on average reduction in fuel bills for a cost of measures of about 25,000. So we thought that was quite reasonable. The more recent ones that we're working on, the cost of the measures varies quite a bit depending on the package, and in particular, if you include a new heating system, we can see there batteries add to the cost quite a bit, but the savings are a lot higher now with these big packages of measures, and we're getting up to maybe £1,000 a year savings, and these are the percentage savings. The payback's around about 40 years on energy costs, so that's still quite high, and probably too high to consider from a private individual point of view. So I'd like to just summarize those surveys, the whole house retrofit surveys. So we can reduce demand with the insulation, the draft stripping, etc. So we can reduce the heating demand, and that reduces the household energy costs quite a bit. I guess the biggest energy cost reductions are due to the renewable energy supply, because electricity costs are quite high. And so the PV, although it costs a lot, it does save quite a bit of energy. We've had quite a bit of experience on battery storage, and that's interesting because battery storage doesn't save energy really. It just enables you to keep the renewable energy you've generated in the day and use it in the house rather than export it to the grid. So what you're saving is the cost of buying energy from the grid at whatever price, 15, 16p a kilowatt hour, rather than exporting it to the grid and getting a very low price. The benefit, the cost benefit then, is round about, something like 1 to maybe 200 to 50 pounds a year. So it's the benefit when compared to the cost of the batteries, which is round about, say, £6,000, it doesn't add up in terms of the lifetime of the battery. So if batteries are to be used, the cost has to continue to come down, and it has come down in recent years significantly. But also the idea that aggregating companies might now put a battery and a PV in your house and manage your energy and negotiate with the energy supplier about when to store energy in your battery, when to take it from the battery, put it into the grid, etc. So these sort of agreements, or these sort of arrangements are now taken off, and in future we're likely to see the battery perhaps become more cost effective when it not only reduces your energy costs as a householder, but it can be used as part of a negotiation with the supplier to ease pressure on the energy grid. So I mentioned at the start we'd be looking at multiple benefits of retrofit. So we've got the energy benefits and the cost benefits that I've talked about, but also if we start to look at these large-scale retrofit programs, and we really need to scale up. At the moment, my experience is mainly in Wales, where we're doing about 2,000 to 3,000 a year on government programs. We really need to get up to about £50,000 a year if we're to deal with something like 300,000 properties in fuel poverty. And if we can get a scaling up, we can create jobs, so there's economic benefits. And there's something like 22 jobs created for every £1 million spent on retrofit. It does increase the house value, so your asset value is increased. You can get more rent if you're renting a house, so there's benefits there. It reduces fuel poverty, and this is really significant because that can have a major impact on improving health. And it's estimated that every pound spent on reducing fuel poverty reduces our health costs by 42p. So that's a big return on the investment. So if we add all these social costs together, for every pound invested in energy retrofits, you get a return of around about £4 in relation to economic benefits and health benefits and in energy benefits and asset value benefits. So there's a lot of return on the investment. The problem is how do you raise the capital to carry out these programs? And we need much more inclusive cost models. So in future, we need not just to look at the payback in terms of energy savings related to cost of measures. We need somehow to include these other socioeconomic costs in the equation. And if we can get that going, we can create a huge industry of retrofits, save a lot of energy, and improve well-being and health across millions of people. So thanks for that. I hope it's been informative. I'm open to questions. So I'll hand back to Katie. Thanks.
Lovely. Thank you very much, Phil. So as Phil just mentioned there, if you have got any questions, please do send them through. Now's your time to get typing. We do have one that's come in already, and that says, so this goes back to sort of where you were, so around 10 minutes ago. Do your energy savings and associated cost savings take into account the expenditure and energy use required for comfort cooling during very hot summer days? So many well-insulated homes need to be cooled down in the summer to make them bearable to the occupants. What are your thoughts?
None of the houses that we've retrofitted have any cooling system, and I think most of them would, especially the solid wall construction with the external wall insulation, would probably not have any cooling requirements. I understand, of course, that new build, especially lightweight construction with poor ventilation, often has summertime overheating. The mechanical ventilation heat recovery also helps with this, so it ensures that there is good ventilation in the summer as well. So I appreciate it. It could be a problem for new build, but not for retrofit. And we've monitored a number of these houses, and we haven't had any issues of overheating.
Okay, you mentioned new build. Someone has asked, has there been any cost comparison study for retrofit or against new build?
I guess the question is really, do we demolish and build new, or do we retrofit? And we have done some studies in the past, and sometimes it's marginal, but it usually favors retrofit. And of course, there's quite a bit of embodied energy in our existing buildings. So it's not only the operating energy and the costs, it's we're losing a lot of embodied energy when we demolish a building. So usually it's more cost effective to retrofit than to build new. Okay,
thank you. Now, I've got a question here about loft insulation. Just looking through this, and it says from somebody having conducted many reports. Now, loft insulation is disturbed after a while by tradesmen, for example. Are there initiatives to install foolproof systems?
Sorry, I missed that. You broke up a bit.
Oh, sorry. Regarding loft insulation, people are asking if there are any initiatives to install foolproof systems so that they don't get disturbed, for example, by tradesmen.
I'm not aware of any foolproof systems, because people will go up into the loft and disturb them, and we've had issues of that when services are put in and the insulation is moved and it's not put back right. And of course, you also get the insulation will sag over time, so it won't retain its thickness. And that's why we usually, even if there's insulation already in the loft, we would top it up to a new level. So foolproof measures, I'm not sure of any. I don't know of any, but we would always recommend topping up the loft insulation. And even though sometimes the loft insulation, if there's loft insulation there, people think it's not worth it. But because it's been disturbed or it's reduced in depth, the top up will get you to the required standard, even if you think it's not worth it. It usually is because of this disturbance effect.
Okay, thank you, Neil. I hope that answers your question. So on to your question from John. He has asked, do the costs include the professional fees for detailed survey and the design work that's required?
The ones that I've looked at, the professional fees are there, but I guess because a lot of them are based on research, the modelling is done by the project. The first 5 houses I showed were tendered out for a company to do. So that included all the fees and everything. But the more recent ones, in particular the modelling that's been done, that cost isn't included. But all the usual fees are there.
Okay, thank you. I've been asked, with regard to the properties, have any been surveyed following the retrofit to identify if there are any resultant defects, such as the example here is moisture trapped in the walls, for example?
They're all being monitored. Some of these are quite recent, so some of the latter ones I showed, we're only just retrofitting now, but they will all be monitored. The first 5 that we looked at we haven't had any issues with those. I guess the only issue we had was with the batteries. Some of them we used lead acid batteries. At that time, they seemed to be the cost-effective way. In the meantime, the battery costs for lithium-ion have dropped probably by 50%, and the lead acid batteries didn't work. They deteriorated over time. They lost their charge, and it was they weren't really suitable. So we've gone back and replaced them with lithium-ion. The earlier large-scale retrofit programs I've showed, there has been studies on those and similar programs that identifying issues, in particular with external wall insulation and the problem of detailing. And because a lot of these programs, they're government funded, the funding is often delayed, but they still have to be done within a time period. They're often quite rushed, and that is an issue with the retrofit industry, I think. The funding is erratic. The industry then expands and contracts quite a bit, so we don't retain the skills and the learning, and then we do get problems. So we really need to scale up retrofits and professionalize the industry to avoid these sort of problems.
Okay, thank you. Now, a question here, have there been any issues with tenants not understanding how to maximise the benefits of the technologies? For example, they may turn off heat pumps just because they think it's costing them money. So how do you kind of make people aware of the benefits?
With the whole house retrofits, we do engage with the tenants. We talk to them, we tell them, how to use the system, and generally it's been okay. We don't try to introduce anything more complicated than necessary, so we try to keep everything simple. And when we change the controls, we try to make sure that they are simple to use controls. So in general, we haven't had any main issues with the tenants not using them properly. I think in the larger scales programs that I talked about, they tend to be 1 or 2 measures. So, if it's external wall insulation, then there's not much that can be interfered with there. So I think as long as you instruct the tenants, and I guess that's what whole house retrofits are about. It's not only designing a package of measures appropriate for the type, but also type of house, but also to engage with the occupants to make sure that they understand what's going on, because they need to be aware of any disruption in the program itself, and then they need to be aware of how to use the house after it's been retrofitted.
I think that's absolutely right. I think communication is key, isn't it?
It's very important. Yeah.
Sorry. And then I've just had a question here. Has there been any? Is it been found that there needs to be roof strengthening to facilitate roof panels?
Not on the houses we've looked at. Not because you're taking the roof off, the existing roof off, and the panels that you put on are not on. Are instead of the existing roof. So there's very little change in load on the roof.
Okay, great. Thank you for that. That pretty much covers all the questions that have come in for this morning's session. So what I think I would do is, if you're out there and you've got one last burning question, this is your time to, like I say, type furiously. But I think just a comment that has come in says regarding this morning's presentation says that it just shows just how much expertise is required to both understand and then to choose the best options. I think that's one of the key messages from this morning.
Yeah, I think that's right. It's exactly what the situation is. We really need a professional industry to do our retrofits. It can't be done by a low-skilled workforce. There has to be a lot of thinking behind it. The workmanship has to be good. It has to be checked and evaluated, and then we get the performance. So that's precisely what I guess I've been trying to get over, is the need for a professional retrofit industry.
Excellent, thank you. There's just one question just popped in, which I'm going to ask, burning subject of the day. And maybe it is a bit of an open-ended question, but with regard to what funding will be available once we have left the EU. Leave you with that one.
Well, for research projects, we remain to, we don't know. And some of the retrofit programs do access European funding. I guess the Eco 3, that comes from the energy supplier, so that will continue for a while. But I think we can't depend on subsidies forever, and we have to get our cost. I think where I ended up was we need a cost model to look at all the benefits, to put a cost on the health benefits, the economic benefits, the asset value benefits, as well as the energy benefits. And once we've got that cost model, we should be able to justify somehow carrying out these whole house retrofits.
Okay. I'm going to ask.
The challenge is being able to bring all the costs together. There are lots of investment opportunities, people wanting to invest in big programs, but they need to deal with one entity who can bring all these cost benefits together.
Yeah, understood. Now, I'm just going to ask one quick question that's come in, and it talks about the upgrades. And it says, will any of the upgrades need to be replaced or maintained before full payback is achieved? So, for example, the lithium-ion batteries and the solar panels. Yeah,
the batteries are the main one, because probably, if we're just looking at the cost benefit to the occupants, then they don't add up, because if they save £200 a year and they cost £6,000, and they last 15 years, then the sums are quite easy. They don't achieve the payback. So the cost will come down, but also there are ways in which they benefit the energy supplier in taking the pressure off the grid. And if that cost benefit can be included, then they start to become a package. But what we're looking at really is a package of measures. We're looking at a whole system. Some of the elements of that system won't be as cost effective as others, but unless we look at a whole system, we're always going to be looking at elemental. So the whole system approach means that initially some of the measures won't be as cost effective as the others. But if we want to drive costs down and scale up, we have to adopt a whole system approach.
Excellent. And I think what I'll do on that note is I'll close this morning's session, so I'll close the questions. So thank you to everybody who sent questions in. Yet again, that's been a really good session of questions for Phil. So what I want to do is thank you for your time this morning, Phil. That's been a really good session for us. I hope everybody's found it really interesting and informative. If you think of any questions that, after you've gone away from this morning's session and want to pop them over to us, then please do, and we'll answer those separately. So usual sort of rules apply. This webinar session has been recorded and will be popped up onto our YouTube channel later this morning, and you'll get a link to that. So if you did miss any perhaps at the beginning, or you wish to send it on to colleagues that may also benefit from this morning's subject, then please do send that around. CAD members, log into the website, add an hour CPD for this morning's session, so you can add that against your record. And then all I now need to do is let you know we're next online next month on the 13th of March, and we're actually now looking into ventilation. So Compliant ventilation in domestic dwellings. That will be our subject for the 13th of March. Again, a link will come round to you in an email shortly once I've got those ready. So thank you all for your time. Again, thank you for your time this morning, Phil, and your expertise. And we will see you online again next month. Thank you.